Hello students, in this video we will see the bitwise operator. Bitwise operator in C. So this bitwise operator, it is an operator used to perform the operation on a data at the bit level. So suppose when we perform the bitwise operation, then it is also known as a bit level programming, and it consists of the two digit like here 0 and 1. So these two digit are involved in this, and it is mainly used in the numerical computations, and we use these bit level operators or this programming to make our calculation faster. So first let's see the table of bitwise operators. So here we will be using this operator. So this operator is called as a bitwise and operator. Bitwise and operator. So single ampersand operator you can see, and let me write here the next operator. So this is what the bitwise or operator. Bitwise or operator. The next operator is this operator. So this is called as a bitwise exclusive or we can say that XOR operator. So exclusive or operator. Next one is the negation operator, or we can say that the ones complement operator. Ones complement operator. The next one is the left shift operator. Left shift operator. And the next last one is what? The right shift operator. Right shift operator. So these are the bitwise operator. After this we will see the truth table of this bitwise operator, and then we will go with the examples. So the first, suppose here the suppose a is your variable or the operand, b is the next operand, and we want to perform suppose bitwise and operation on these two operand, bitwise or operation on these two operand, bitwise exclusive or on these two operand, okay, or we can say that the negation of a. So this we will see one by one. So suppose see this is what the truth table. One. So for this bitwise and operator, it is denoted by, you can see here, single and or the ampersand sign, and the two operand you can see on the both side of this operand. Okay. So if the here the corresponding bit of both the operand are one, that means here for this last one, then and then your output for this and bitwise and will be one. Otherwise output is 0. Okay, so this is for the bitwise and operation. The next for the bitwise or operator. So here for bitwise or operator, if you will get the for both input a and b, so you will get the 0, and for 0 1 it is 1, 1 0 it is 1, and for 1 1 it is 1. Okay, so if the bit value of any of the operand is 1, then you will get the output as a 1, otherwise it is 0. Okay, so this is for bitwise or operator. The next one is the bitwise exclusive or operator. So here this you can see, this is the symbol for the exclusive or operator, and the two operand are written on the both side of this exclusive or operator. Now if the corresponding bit of any of the operand is 1, that means for this you can see for 0 1, so it is 1, that means corresponding bit of any of the operand is 1, then the output would be 1, otherwise it is 0. That means here we can write 1 1, otherwise it is 0. Okay, so this is for exclusive or. And for we can say the complement operator or the one's complement operator. So it is actually the negation, we can say, or the reverse. So it takes only the one operand. You can see here it takes only one operand, so that's why it is also called as a unary operator. Okay, and when we apply the complement operation on any bit, so 0 becomes the 1 and 1 becomes the 0. So likewise, so you can see here I am doing the negation of a, so it is reverse. See, here 0 is there, so 1, 0 is there, 1, 1 is there, so it is complement is 0 and 1's complement is 0, or the negation, we can say. So this is what the bitwise operators table. Now we will take one example. So suppose the in example we will see first how to perform that bitwise operations. Okay, so suppose let's say our value of x is equal to 40 and our value of y is 80. Okay, so these two values has given in our programming, and we want to perform the bitwise anding operation, like we want to perform this bitwise and bitwise or. So these two we have to perform. Okay, so for this, how it will perform. So first, this is what the decimal number. Okay, these two are the decimal number, so we want to convert this decimal number into the binary number. So how to do that? So first, divide this 40 by 2. Okay, divide this for 40 by 2, and here we will write the quotient here in this section. You can see the divide 40, okay, by 2, so you will get the 20 as the quotient and 0 as the remainder. Okay, again divide it by 2, so you will get the 10 as a quotient and the 0 as a remainder. Again divide it by 2, so you will get the 5 and the remainder as a 0. Okay, again divide it by 2, so here you will get the 2 as your quotient and 1 is your remainder. Again divide it by 2, so 2 2 ones are 2, so you will get the 1 as the quotient and 0 as the output. Okay, so let me move the page. So just a minute. Uh-huh. So again we will do once again for converting that 40 decimal number into the binary number. So let's say suppose you will have the 40 as the number and you want to convert this 40 number into the binary. So you are dividing it by 2, and here you are writing the 20 as the quotient and 0 as the remainder. Again you are dividing it by 2, so here you will get the 10, here the remainder is 0. Again you are dividing it by 2, so you will get the 5 as the we can say the quotient and the 0 as the remainder. Again you are dividing it by 2, so here you will get the 2 as a quotient and 1 as a remainder. Again you are dividing it by 2, so here 2 ones are 2 and your remainder is what, 0. Again you are dividing it by 2, so here you will get the 0 as your quotient and 1 as your output. So you are repeating this process till you get the 0 as a quotient over here. Okay, so here I will get the 0, so I will stop here. Now this bit is, we can say that it is the LSB bit. So what is that LSB? LSB is nothing but the least significant bit, and this bit is called as a MSB, that is the most significant bit. Now I want to write this number into binary number, so let's take this order from LSB to MSB we can take. Okay, now just read the, or just count this number, 1 2 3 4 5 6. So this is 6 bit, and I want this 40 number Okay, earlier I have written that ki x is equal to 40 and y is equal to 80. Okay, and we want to perform this x and XOR operation. Okay, so this 40 number I want in 8 bit or 1 byte, we can say. So here at the LSB side, let me add the 20 over here. Okay, so why I am adding 20? Because I want this number in a 8 bit or 1 byte. So now you can count, and now you can write from this direction, from LSB to MSB. So you can see here 0 0 1 0 1 0 0 0. So this is what my x. So x binary representation. Now same way we can do for the 80. Okay, so here for 80, let me write for 80. So again it is 40, remainder is we can say the 0. Again here 20, remainder is 0. Divide 10, remainder is 0. Do the same way, like divide by 2 and write the quotient and remainder over here. Again 2, here remainder is 1, and 2, here 1 0, and for remaining 1, like 0 and 1. Now you can see this is what my LSB bit and this is what my MSB bit. Now you can count 1 2 3 4 5 6 7. Here just add one more 0 at this side and just write the number over here. So y is equal to what? 0 1 0 1 0 1 0 0 0 0. Okay, so this is what my y. Now what I want to perform, I want to perform this operation like x at x bitwise and y. That means here I want to perform the bitwise ANDing operation. So earlier we have seen the table for bitwise ANDing operation, right? So what that table says, that table says if 0 0 is there, so you can write the 0. Again 0 0 0 0 0 0. 1 0 is there, so here again it is 0. 0 1 is there, it is 0. 1 0 is there, it is 0. 0 1 is there, it is 0, and 0 0 0. That means you will get the 0 as the output. Okay, for this operation, bitwise operation, you will get the 0 as your output. Okay, when you type this code on a computer, so you will get this 0 as the output for this operation. Okay, now the same operation I want to perform like on x and y variable, but the OR operation, bitwise OR operation. So x is what? 0 0 1 0 1 0 0 0, and y is what? 0 1 0 1 0, and then 0. Now I want to perform the exclusive OR operation. Okay, so sorry, bitwise OR operation, not exclusive, bitwise OR operation. So in bitwise OR operation, you can see if only one 0 is there, 1 0 is there, we will type the 1, or we will take the 1 1 0 1 0 1 0. Now you can see this number I will get. So this is in the binary form, right? So I want to convert that into the decimal form. So how to do that? So this is what in a binary form, and I want to convert this into the decimal form. So here you can see that we want to do the reverse from binary to decimal. So this is what? 2 raised to 0th position. Next this is 2 raised to 1 position, 2 raised to 2 position, this one. And here this one is the 2 raised to 4 position, this one is 2 raised to 5th position, this one is 2 raised to 6th position, and this one is 2 raised to 7th, and this one is 2 raised to 8th position. Okay, that means you can see here this 0 is there, so this 2 raised to 0 value is 0, plus this is also 0, this is also 0. Okay, now you can see here for this. Okay, 0 1 2 3. Actually here I forgot to write, this is 2 raised to 3, 2 raised to 4, 2 raised to 5, and 2 raised to 6, and this is 2 raised to 7, because we have started from the 0th position, so obviously it is 2 raised to 7, not 8. Okay, so this 3 is 0. Now here you can see for this 1 into 2 raised to 3, so it is what? It is 8. Okay, now again plus 2 raised 1 into 2 raised to 4. Okay, so it is what? 16, plus again 1 into 2 raised to 5, it is 32, plus 1 into 2 raised to 5, sorry, 2 raised to 6, it is 64, right? And for the last bit you can see 0 is there, so 0 into 2 raised to 7 means 0. So if you just add this, so you will get the 120 as your output, as a decimal number. So when you are performing this like x exclusive or y, so you will get the 120 as the direct output on the compiler, okay, on C compiler. So it is that at the back end this type of operation will perform. So this is bitwise or operation, okay. Now we want to perform the next operation like exclusive or operation, okay. So for that again we have this exclusive or we want to perform, and we have the x as the 0 0 1 0 1 0 0 0, and for y we have 0 1 0 1 0 0 0, and we want to perform the exclusive or. So in exclusive or, if both the operand value are same, we are writing the 0, otherwise we are writing the 1. So you can see this, and again here this output is same like 120 as the decimal value. So if you perform the exclusive or, you will get the 120 as the output. So these two operator we have seen like bitwise and operator, bitwise or and bitwise exclusive or. Now we will see one's complement, as we have seen like if the 0 is there, so we will get the 1 as output, and 1 is there, so we will get the 0 as the output. So suppose this is our a value and we want to perform the complement of this, so these are the reverse. So you can see this type of output is there for the negation operation or the one's complement operation. So this is all about the bitwise operator in C. Now we will move to the next operator like the uh, left shift and right shift operator. Just a minute. Let me share my another window. Yes, so we will see the next operator. So the next operator, next bitwise operator. So bitwise right shift operator. Right shift operator, or we will see the left shift operator as well. So in right shift, or how to write that right shift operator. So you know that this is the symbol for the right shift operator, and the for left shift operator it is the reverse one, we can say. So first we will see the right shift operator. So suppose your x is your variable and you want to right shift that variable by 1, okay. And same earlier example we will continue like x is equal to 40, and we know that this is decimal value and binary value for this is 0 0 1 0 1 0 0 0, okay. So this is the binary value. Now what we want to shift that x value to the right side, okay. So right side means as normally our right hand side, we want to shift this value to our right hand side, okay. So how will we how to do that? So here you can see this is the suppose zeroth position, one, second, third, fourth, five, sixth, and seventh, okay. So these are the position, and you can see suppose likewise the boxes are there and we want to shift that, okay. So this 0 we will shift here, right shift, we are doing right shift. This 0 is here, again this 0 comes here, this 1 comes here, we will be shifting like this, okay. 1 here, and again this 0 comes in the this ones place, again this 1 at the 0, and this 0 over here, 0 over here, and here you can see one empty space is there. So here what we are doing, we are just adding the 0 over here. Okay, so now you can see this is what x right shifted by 1. Now what we want to do, we are skipping this now, because we have performed the right shifting, so this is discarded. Okay, now we want to convert this number into the, into which, into the decimal number. Okay, into decimal number. So same way, this is the 2 raised to 0th, 0th position, so it is 0. 2 raised to 1 position, it is 0. This is 2 raised to 0, 2 raised to 1, 2 raised to 2 position. So we will directly take this 2 raised to 2 position. 2 raised to 3 is the again 0. 2 raised to 4th position. Okay, so 2 raised to 4, then 5, 6 and 7. So remaining are the 0. So that's why I'm not considering this. So here 2 raised to 4 is what? 16. And 2 raised to 2 is what? 4. So you will get the 20. Okay, that means when if you type this on the compiler, so like you have given the int x is equal to 40, and you are just printing just a minute, let me write that sentence over here. Suppose you have written like this: int x is equal to 40 and printf percentage d x is right shifted by 1. So you will get this 20 as the output. You can see here 20 as the output. Now suppose you want to shift this x by the 2. Okay, this 2 you want to perform it one more time. So what we are doing, we are first performing this, like x is right shifted by 1, and we are taking that as a input for the next shifting. Okay, that means this we are taking this whatever we have written, and again one more time we are shifting. So what is the first one? 0 0 0 1 0 1 0 0. So this is the output of the x is right shifted by 1. So this is the output of this. Output of x is right shifted by 1. We will taking this as it is, and we are shifting this. So here, and this we will be discarding. So here 0 1 0 1 0 0 0, and you can see here this is the empty. So here let me add the 0 over here, and this now we will considering. So this is we discarding. Okay, discard this one. Now again convert this. So you can see this is the 2 raised to 0th position, 2 raised to 1 position, 2 raised to 2, 2 raised to 3. So let me take only 2 raised to 1 plus 2 raised to 0 1 2 3, 2 raised to 3. Okay, so 2 raised to 3 is what? 8, and 2 raised to 1 is what? 2. So this 8 plus 2 is what? 10. So you will get for this x is right shifted by 2, so you will get the output as a 10. Okay, so this is for the right shift operator. Now we will do for the next, like left shift operator. Left shift operator, and this is the symbol. So suppose we want to perform the left shifting by 1 on the on same variable, we can say on the x, we can say. So suppose 0 0 1 0 1 0 0 0. So this is our x value, like 40 value, and we want to shift it by left. Okay, so here you can see this we are shifting to the left hand side. Likewise this, again this 0 is at this place here, this 0 is at the this place, this 1 is at this place, again 0 is at this place, this 1 is at this place, again this 0 as a this place, and here this 0 is remaining. So we will be assigning that 0 over here. Okay, so this is what our the what we can say, the left shifting. Okay, now just I want to convert this number into the decimal number. Okay, so here you can see that this is 2 raised to 0. Okay, 2 raised to 0, 2 raised to 1, 2 raised to 2. So from here we are just counting that 0 1 2 3 4, 5, 6. Okay. So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. So this one bit is what? 2 raised to 4, and plus this one bit is a 2 raised to 6 bit. So 2 raised to 6 means what? 64, and this 2 raised to 4 means 16. So which is equal to 80. Okay. So this is 80. Now the output of this x is left shifted by 1. So output is what? 80. Okay, so same you can perform one more time for the, like, for this x is left shifted by 2. So the same, this output you keep as a input and you perform the shifting. So I will directly show you how to shift that. Okay, so say, see, suppose this is your this input I have taken. Okay, so output of this I have taken, output of this x is left shifted by 1, I have taken input over here, and I am shifting that. Okay, so you can see this one goes here, this goes here, this 0, this one goes here, and this 0 comes here, 0, 0, 0. You can see, and here one more space is there, so you can just add the 0 over here. Okay, now you can see this is 0, 1, 2, 3, 4, and 5. So 2 raised to 5th position having 1, plus 2 raised to 6, and 2 raised to 7th position having the 1. So we will just use this one. So 2 raised to 7 is at what? 127, and 2 raised to 5 is the 32. So we will get the 160 as the output for this x is left shifted by 2. So we will get the output as a 160. Okay, I hope you understood this left shift and right shift operator. So when you just type the code on the turbo compiler, so you will see this type of output, and the logic behind this is this. Thank you.